Before we start in with division of rational numbers, we should begin with a few integer problems just to test the water and get a bearing about what we're trying to do with division. So let's start with this problem. How students would read it is 15 divided by 5. But what does that really mean? Our language should match with what our goal of the problem is. And it says 15 items are being put into groups of 5. Or another way we can say it is, how many groups of 5 can I make with 15 items? So let's see. If I take 15 circles, I'm trying to make groups of 5 until I don't have any more. So I can see that there's one group of 5 that would work, another group of 5 that would work, and a last group of 5 that will work. Once they're all highlighted, I don't see that any remain. I can easily see that 15 items being put into groups of 5 would mean I have 3 groups. 3 groups of 5 would give me 15 items. So let's try another one. This time, students would see 16 divided by 4, or 16 items being put into groups of 4. Or a last way, you can ask yourself, how many groups of 4 can I make with these 16 items? So again, let's see. I take 16 chips, 16 circles, whatever you want to call them, and I'm going to group them in chunks of 4 until there are no more. There's one, and another, and another, and another. There are no more remaining, and I can easily see that there are 4 groups of 4. So my answer, when I take 16 items being grouped into 4, is 4. The trickiness is going to come in when we tackle our next example. This one. 6 divided by 1/2. Or, if I have 6 items, how many groups of halves can I make? Ooh, that language is horrible. So let's try another way. How many halves are in my group of 6? That may work. Or what about a last way? If I have 6 items, how many times can I make groups of 1/2? That can make a lot of sense for students. How many times can I make groups of 1/2 if I start with 6? So let's start with 6. I have 6 squares on the board. 6 whole squares. How can I take each of these 6 squares and make them into halves? Well, I can divide each of those squares and show that there are 2 halves in each whole. So of my original 6, I take each of the halves, and there are 2 in each whole, so I'm actually multiplying. So let's take a focus on these orange squares. Look at these 2 equations, and let's figure out how they're similar. What are some conclusions that we can draw? Well, I see the 6, I see different signs, but I see 2 numbers that look kind of similar. Oh wait, that's right, they're inverses of each other. They are the multiplicative inverses or the reciprocals. So really, with those changes and those connections, similarly to addition and subtraction, division is multiplication of the inverse. I keep my first number, I change my sign, and I use the multiplicative inverse of my second number. 6 divided by 1/2 is 12. I can make 12 groups of halves with 6 individual items. 6 times 2 over 1 is 12. So I hope this made sense, and I will look forward definitely to seeing the rest of your podcasts. So thank you for your time.